In this lesson, we're going to look at simplifying ratios and solving ratio problems. Some of you might get onto looking at using ratio as a map scale. So first of all, simplifying ratio. Let's have a look at this worked example. So two friends, Alice has 60 pence and Sarah has £1.20, and we want the ratio of Alice's money to Sarah's money, and we want that in its simplest form. So the first thing always to do with ratio is to use letters above each side of the ratio so we know which way round it is, because which way round is very important. So we're going to have A for Alice and S for Sarah because it wants Alice's money to Sarah's money. So we've got Alice 60 pence, let's write that underneath the A, and Sarah £1.20 underneath the S. Now, before we can simplify a ratio, it must be in the same units. So it's easier here to work in pence because then we don't have to worry about decimals. So I've got 60 pence to 120 pence, and then I can just simplify my numbers. So I can see here that I can divide by 10 because both sides of the ratio have got a 0 on the end. So if I divide both sides by 10, I get 6 to 12, and then I should be able to see I can go one step further and divide both sides of the ratio by 6. So we're simplifying a ratio here by dividing both sides of the ratio by the same amount as far as we can go. So we get there that the simplest form of the ratio is 1 to 2. So for our thinking questions here, not so much questions but just things to think about, we simplify a ratio by first of all converting to the same units, and secondly dividing both parts of the ratio by the same amount. Let's have a look at a problem-solving example now. So I've got the ratio of men to women is 7 to 11. So again, first of all, we're going to write M for men and W for women and put the 7 to 11 underneath so that we make sure that we've got the ratio the right way round. Now I'm told there are 175 men, so we're going to start by writing 175 under the M, the men's part of the ratio. So I can see here that I must have to multiply 7 by something to get to 175, and I need to find out what I've got to multiply 7 by to get to 175. So in order to work out what I need to multiply, I need to actually do 175 divided by 7. Okay, so let's just make a note here. We want to multiply both parts of the ratio by, how am I going to work out what I need to multiply by? Well, let's do the opposite. Let's do 175 divided by 7. So 175 divided by 7, if we haven't got a calculator, we could do a quick bus stop to work that out. 7's into 17 is 2, and 2 remainder 3, and 7's into 35 is 5. So I now know that if I do 7 multiplied by 25, I'll get to 175. So that means I need to do 11 multiplied by 25. And again, you might have to do a written method to do that if you are not working with a calculator, but that gives us 275. 11 times 25 is 275. So I know then for 175 men, there must be 275 women. So that's my final answer. So if we look at the thinking behind this, okay, so we can solve ratio problems by multiplying both parts of the ratio by the same amount. What I'd like you to do is pause the video and have a go at these your turn questions in your book. Question 1, a straightforward simplify without worrying about units. question 2, you're going to have to convert both of them to centimetres and then simplify, and then a problem solving one there to try. So pause the video and try those now, and then I'll give you the answers. So hopefully you've restarted the video after trying the your turn question. So the answers we should have is 3 to 5 for question 1, 3 to 10 for question 2, and question 3 you can see my working there, but for 12 boys there would be 18 girls. Right, so now I would like you to look at exercise 15A from your My Maths textbook. I have scanned in this page of your textbook, and it's in the files section under the ratio and proportion folder. So your challenge is question 1 part A to H, super challenge is question 2 A to H. So start with the challenge or the super challenge first. If you finish the super challenge, you can start the hyper challenge, which is the problem solving questions 3 to 5. Before having a go at question 4, because that involves map ratio, then I want you to watch the next example of the video. So you can pause the video for now, start on the challenge or the super challenge, and if you get to question 4 of the hyper challenge, restart the video to look at the map example. So here's an example as to how we use ratios for map scale. So let's just have a look at it bit by bit. A map scale has a map has a scale of 1 to 200. So this is giving me the scale of the map, and it's saying that one section of length on the map represents 200 sections of length in real life. So if we're asked what does a distance of 8 centimetres on the map represent in real life, so let's start with our ratio, and again we're going to write the map on the left because the smaller section of length is obviously going to be what's on the map, and the 200, the larger section of length, is going to be what's in real life. Now we're going to work with centimetres because we're starting off with a distance of 8 centimetres on my map. So 1 to 200 means 1 centimetre on the map represents 200 centimetres in real life. So what we're going to do now is we're going to say, okay, well, I don't want 1 centimetre on the map, I want 8 centimetres on the map, so I'm going to write that on my map side of the ratio, under the map side. And I can see here that to get from 1 centimetre to 8 centimetres, I need to multiply by 8. So just like before, I need to do exactly the same on the other side of the ratio. I need to multiply by 8. So 200 multiplied by 8, well, 2 multiplied by 8 is 16. Add my 2 zeros back is 1,600 centimetres. So I now know that my real life distance for 8 centimetres on the map is 1,600 centimetres, but we don't tend to work in centimetres in real life, so it makes more sense to convert this to metres. So if we divide by 100 to convert this to metres, that tells me it's 16 metres distance in real life. Part B of this example gets us to work back the other way. We've got the real life distance of 30 metres. What is the distance on the map? So we're going to continue working in centimetres. So the first thing we're going to do is convert the 30 metres into centimetres by multiplying by 100. So 30 metres is 3,000 centimetres. Start with the ratio we've been given again. Map side is 1 and real life side is 200. And we know that means 1 centimetre on the map equals 200 centimetres in real life. So this time, the amount that we've been given is the real life amount, so we're going to write that on the real life side. And we've got 3,000 centimetres on the real life side, so we need to know what to multiply 200 by to get to 3,000. So just like before in the earlier example, to work out what to multiply by to get from 200 to 3,000, we can do the opposite and we can do a division. So we're going to say what we need to do here is multiply both parts of the ratio by, so to work out what to multiply, we do the opposite, so we're going to do 3,000 divided by 200. Now, to work out this division, the easiest thing to do is to write the division as a fraction, and then we can simplify the fraction. So we can divide top and bottom by 10, and then by 10 again, to cancel 2 zeros, top and bottom. So that actually just gives me a simplified fraction of 30 divided by 2, which is 15. So I know 200 multiplied by 15 gives me my 3,000 centimetres. So therefore I need to multiply the left side, or the map side of my ratio, by 15. 1 times 15 is 15. So I can see now that my 3,000 centimetres, or 30 metres in real life, would actually be 15 centimetres on the map. So my final answer, my map distance, is 15 centimetres. Now you should be able to have a go at question 4 on the Hyper Challenge.